Welcome to Algebra Section 7-6% change. We'll begin with our vocabulary for the day. Our first vocabulary word is percent, whole, and part. I actually have a formula here up right at the top of the paper. And if we take a look at this, the first thing is the percent. And whenever we think about percent, we normally will be converting that to a decimal. And percents are always out of 100. The whole, when we're looking at this, is the starting value, the original value, whatever we begin with. And then the part is the change in value. And change is the difference between the starting value and the ending value. So, for example, if I look at 30% of 110 equals 33. If I was to do this, I'm going to convert my 30% to a decimal. I do that by dividing by 100 times 110, because of means times equals 33. When I do my calculation, I end up with 33 on the left-hand side. So I can see that my work actually calculated out to the correct answer. Now, when I'm thinking about percents, wholes, and parts, there's two things that come up. We have something called markup and discount. Whenever I look at markup, the starting value, okay, this is 100% of what I start with. That always has to stay there. Then, because I'm marking it up, like I'm in a store, I purchased something to sell to my customer, I need to make a profit. So I am going to add on a certain amount. And when I add that certain amount on, I have a final cost. So, for example, if my starting value was $110 and I was going to add on 30%, I would have my $33 that I would add on. My final cost for this item would be $143. That's how I do my markup. So I start with 100% of what I began with. I add on whatever I'm going to increase by 30%. 30% of 110 was 33, adding it on. Now, if I'm thinking about a discount, I'm at the same store. The item costs $110 for my customer, but I have a sale today. I have 30% off. If I have 30% off, my change in value is $33. So my final cost would be $77. All right, looking at another example. We have my percent, whole, and part again. My example is this. My original price is $110. I have it on sale for $82.50. I need to find the percent of change. In this case, because the price is decreasing, this is a discount. So, looking at this, I'm going to start with my percent times my whole is equal to the part. So my percent, I don't know what that is. Percent is out of 100, so I have x over 100. My original price is $110. And then the part. That, again, up here is the change in value. So I will be taking 110 and subtracting 82.50. So on the left-hand side, I have 110x over 100 is equal to 27.50. Now, I need to find my percent. To find my percent, I'm going to multiply by the reciprocal on both sides. When I complete that on the left-hand side, the fraction cancels out. And on the right-hand side, I end up with the final answer of 25%. Moving on to my next example. I have my original price of $95. I have a new price of $125.40. This we need to find the percent of change, but this time the price increased. Since it increased, this is considered a markup. Alright, my calculation once again. I start with my percent, which I do not know what it is, so 1x divided by 100 times the original price, which is 95, that is equal to the change in value. Now, the change in value, I always have to start with the highest cost. So I have 125.40 minus 95. We'll complete this process as previously shown. The next example is a little bit different. I have a percent of decrease this time. I actually know my percent. I have my new price of $68.25. I need to find the original price. Since this is a percent of decrease, that means that this is a discount. So my original price is going to be higher than my new price. My calculation will be this. I have my percent, which is 12.5 over 100, which is equal to my original price, which I do not know, which I will call X, and my new price of $68.25. I have to find the change in value. My original is more. X minus 68 minus 25 divided by my original price, which is X. Now, when I look at this, I have two options. I can use cross multiplication to solve this, or I can use solving by simplifying the left-hand side. In this case, I am going to simplify that left-hand side to be 0.125, which is equal to X minus 68.25 divided by X. Now, I need to get my X's together in the numerator. I now have them in the numerator and the denominator, so I'm going to multiply through by X. So I have 0.125X is equal to X minus 68.25. Once again, I have to get my x's together. So I will be moving this 1x right here to the other side. So I will be subtracting 1x from both sides. I end up with negative 0.875 is equal to negative 68.25. I lost my x there, so I got to sneak back and put that in. Now I divide both sides by negative 0.875. And I end with my final answer. X is equal to $78. So my original price was $78. My new sale price was $68.25, which is a percentage decrease of 12.5%. Okay, looking at this next example, it's very similar to the last example, but this time I have a percent of increase of 25%. I have a new price of $8, and I'm going to find the original price. I will be just setting this one up, and you will be able to calculate this one on your own to find the final answer. Percent of increase, 25% over 100 times the original price, I don't know the original price, so I call that X, is equal to the new price, or excuse me, the change in value. Now we have to think about this. The new price has been increased, so that is larger, so I will have 8 minus X divided by X. Just one moment, I got to step ahead of myself. I need to erase that. My change in value is 8 minus x. Now, at this point, I have 0.25x is equal to 8 minus x. At this time, you will be able to finish this on your own. All right, looking at another example. I have a brand new car. It costs $22,450. The manufacturer is running a promotion and selling the same car for $19,082.50. What is the percent discount? So this gives me a huge clue that I have a discount instead of a markup problem. So I'm going to start with this. I'm going to say percent times the whole is equal to the part. So we keep in mind what we're looking for. The question asks, what is the percent discount? So that's going to be my variable x over 100. The whole is the original starting price of $22,450. And the part will be the change in value. So when I look at the change in value, I have 22,450 minus 19,082.50. That is my equation for this. We can begin solving by simplifying the left side and the right side. We have 224.5x is equal to 3,367 and 0.5. Now, dividing both sides by 224.5. My final answer is x is equal to 15. Now, if we recall, x represents our percent, so I would say the percent discount is 15%. Looking at our last problem, Joe invests $8,000. Some of his money is invested in stocks paying 12% per year, and the rest is invested in bonds paying 4% per year. If he makes a total of $680 on his investments, how much money is invested in stocks and how much is invested in bonds? When I'm looking at this, I have two things that I don't have any information about, stocks and bonds. So I'm going to just pick one of them. So I'm going to say X represents the stocks. I know his total investment is $8,000. Well, if part of the investment is in stocks, that means whatever I invested in stocks, I can take away from 8,000, and that would be how much he invested in bonds. Now, I understand that the stocks and bonds have a percentage. So I'm going to make a little table to help me keep this organized. My stocks is at 12%. Written as a decimal, that's 0.12. The bonds invested at 4%. That is a decimal of 0.04. Now, I know that he makes an investment of $8,000. His total return is $680. So in English, if I take his stock investment, add it to his bond investment, I end up with the total earnings. Okay, so my stock investment is X, and I'm earning 12%, so I'm going to take 12% of X to get me how much my interest would be for the stocks. Plus, I know I have 4% on bonds, and I invested 8,000 minus X, and I know that has to equal $680. That is my final equation for this. We'll end here, and you can complete this on your own.